Hi, I'm Paul Beckwith, the University of Ottawa Laboratory for Paleoclimatology, also with Carleton University Department of Geography and Environmental Studies. So, because of the importance of this major flooding catastrophe that hit Ottawa, and I'm going to talk in detail about the path of the water from one of the northern reservoirs, Temiskaming, and also from Des Jochems. And the reason I'm talking about those particular regions is because these reservoirs have the largest discharges. So 2788, so this is May 4th, 5th, 6th, 7th. The rapid spike in water appeared to be, the rapid rise in water appeared to be on May 6th. And just to remind you, if the gauge is correct, the rise of water was a centimeter every 5 minutes for 100 minutes, starting at about 10 in the morning on May 6th. And then after 100 minutes, it rose 1 centimeter every 12 minutes for another 60 minutes. So it rose another 5 centimeters. So it rose a total of 25 centimeters. So the question is the gauge correct? Why did this water spike happen so fast? Where's the water coming from? Okay, and I argue if it was just from rain, the rise wouldn't have been so sharp. It would have been spread out over a longer period of time. So let's have a look at the course of the water through the watershed. So keep in mind these two are of the reservoirs that we have data from the Rideau Valley, or from the Ottawa Regulatory Board, ottawariver.ca. We have these numbers from the reservoirs. Okay, I'll just remind you where they can come from. Right here. Okay, so these are the reservoirs. There's data on the reservoirs and discharges day to day. So I just created a spreadsheet bracketing the location when that water spike looks to be there. Okay, so going back here to Google Earth, I'm going to start up at the Lake Temiskaming. Okay, so with Google Earth, right, you can zoom in and out with the slider. So this is a large northern lake, a reservoir, and the pointer, the hand, is elevation 183 meters. Okay, 183 meters, should be about the same. 180 it says there. Okay, 178. Okay, so there's some water flow down here. Those numbers are correct, and we go through here into Temiskaming. Okay, and then we go down, so I'll just follow the course here. Now you'll notice there was a switch here. Okay, so this image date was done in the summer, and this image date, you can see a sharp line here, which is an artifact of the way these maps are stitched together. This is done in the winter, in February. So there's ice covering lakes and the river here. Okay, so let's zoom out and let's keep going down river. Okay, so remember from the Temiskaming Reservoir, there's a fairly large discharge. Okay, that's this guy here. So the maximum, the upper limit is 179.56. So if I take that and subtract the existing level on May 4th, that gives me the freeboard in meters, which is the distance I can go to get to the upper limit. So one question I immediately have is what sets that upper limit? Could that have been kept higher, keeping some more of the water back? So this number is decreasing a bit here as the flow is increasing. Okay, so just referring you to that. So if we go back here, okay, so we have a hydro plant here. This is the first one we come to, Le Cave Dam, a dam and a hydro plant. Okay, so what's going on here? What's the difference? We can look at the difference in water levels. Okay, the level is 168 meters here. 167, 168. Okay, there's a bit of ice on there. That'll throw me off a bit. 167 meters. Over here, 152 meters. 153 meters, 152 meters. Okay, so take those numbers, 152 meters, 168. It's about a 16-meter drop through this dam. Okay, hydro plant. Okay, so let's keep moving down river. And there's another, so here we are in Mattawa. And you can check the level here, 152 meters. Same thing over here. The river's just running through. I put a question mark. Is this a run of the river hydro? You know, you could look it up and see. I mean, maybe these are just pylons, and the water's hitting the pylons, and these rapids are created from that, or maybe it's a run of the river system. Okay, but it's not going to be storing any water or blocking any water. Now look at the elevation here. It's 152 meters. So now let's go down river. Okay, closer to Ottawa. Here we go. We come to this clock place. Now this was identified as a choke point. Remember the Kelly Egan article talking about the water levels being low on the river here, record low, and the idea was that you have to have low river here so you get water flowing through this choke point. If I look at the elevation here, it's 152 meters, which is the same as Mattawa. So if there was a blockage here and the river started rising here, it would back up and it would flood out Mattawa. Okay, that would protect Ottawa, but the people in Mattawa wouldn't be very happy. Maybe we should move this somewhere else, and then we could flood out this whole land in future. I don't know. That's sort of. I mean, we got to think of ways. You know, we can't have this damage occurring in Ottawa and Gatineau from the Ottawa River. You know, with this 1 in 100-year event happening every 10 or 20 years. Okay, so anyway, we'll follow through the river here, and I've marked in red the places where the river was identified as being very low. This is Stonecliff here, and you may recall that the Kelly Egan article, which I discussed in a previous video, has a picture of Stonecliff. Okay, very low water level at the Stonecliff boat launch, Sunday, May 7th. So we have record high levels further down river, record low levels here, you know, with the explanation that, you know, we have a whole bunch of bathtubs connected by pipes, and if the pipes block up, the bathtub is going to rise the water, and that could flood out of town, so we have to have low flow or low water level in there to deal with that, right? So, okay, so this is Stonecliff, and then we come to the Des Joachim, and you'll remember, hopefully, if I can get my spreadsheet back up, this is the Des Joachim Reservoir. Okay, where the flow rate is the highest on the whole system out of all the reservoirs. And the upper limit minus the lower limit gives you the freeboard. So it's almost 2 meters, almost you know, over 6 feet, 6.5 feet. And then that reduces slightly over those days when we had the major flooding downstream. So the question is, you know, could we have cut back on the water, on the discharge here? Brought up the freeboard, you know, to close to, not overtopping, but closer to within, you know, much closer levels. You'll notice the freeboard is very small, you know, for some of these locations, so we could have had a bit less water out, you know, if we'd known all that water was going to go down and flood out, you know, sort of finish off people, you know, around Ottawa and Gatineau. Okay, so that there's all kinds of questions. I mean, this is all I'm doing is bringing all these questions to light here. So let's have a look at these stations here. So there's the one dam and generating station here. So the elevation here is 137 meters. The elevation here is 120 meters. So that's a 17-meter drop. You know, nice drop to generate all that power. And we've got this other station up here. Again, the 137 there, 120 there. So about a 17-meter drop, which makes sense. It should be the same at both. Okay, so this is where massive amounts of water are coming through here, right? But the freeboard, there's a couple of meters of freeboard. This is a fairly large, very wide area here. We could have stored a nice chunk of water there and cut back the discharge rate perhaps. So let's go back further down. Okay, where does the water go? Comes around, spins around here. There's some very narrow sections obviously here. I wonder if all this area was flooded out where there's not people living. Right? I guess it depends. You get here, and what do we have here? Okay, we have the Chenot generating station, 82 meters, 79 meters. Let's go closer, 79 meters, 82 meters. This looks like a run-of-the-river type station, no ability to hold back water. Okay, so you can determine all these things yourself from Google Earth, and then we can come closer and closer to Ottawa. And here we come to the Chats Falls generating station. Okay, water level here, 71 meter. Down here, 55 meter. So that's a 16-meter drop here. And, could we have increased the water here slightly? I don't know. I don't know the freeboard of these generating stations. I just have it for the upstream reservoirs, right? There's lots of... This is where we used to have the gauge, right? We used to have a gauge here, but we stopped collecting hourly discharge rates in 2012, unfortunately. So we don't have a second gauge which we can confirm to what we're measuring later on in Britannia. So all of this region in here, was flooding, severe flooding, lots of houses. This is the Fitzroy Harbor houses. We can go back in closer to Ottawa, zip along here to Ottawa. And here we have Britannia Bay. Okay, now I do want to remind you, okay, so Britannia Bay, this is where we have this data in Britannia Bay. So we have our river gauge here measuring a big spike there, which we're trying to identify the source of that spike. It doesn't seem like gauge error to me. And we can see that the previous record was 60.24 meters, and we've got 60.45 at that location. Okay, again, going back here, this is the only gauge. We had one here and it stopped in 2012. It's the only gauge. So, are we going to say, okay, we got a faulty gauge here, the water didn't rise so fast. Well, how are we ever going to confirm that? We don't have any other gauges. If you live in the flood area, hopefully there was some kid doing a science project or something, putting notches on the side of his house, as the water was coming up. So you see the water rushing up, put a notch, measure the time, with your watch. See another notch, measure the time. We need some verification of these water levels. Right, 1 centimeter every 5 minutes for 100 minutes, starting at 10 a.m. on May 6th. Then 1 centimeter after that, crazy rise. I mean, this is what, if we need some independent confirmation of this to say for sure whether that gauge is correct or not. But like I say, I've got these other images here. The gauge has been working an awful long time. Sure, is the gauge working here? And working here, and then it stops working here, right? Or did it, maybe the rise was a little bit lower and it was measuring hourly, what measures the water level and the flow. This will be some propeller spinning through, measuring the flow. This will be some level, different type of device. Are they both going to fail at the same time? They're both going to record accurately stuff here and not here. So there's all kinds of questions, right? Right now there's a lot more questions than answers. So the purpose of this video series is to, ask these questions, and hopefully we start getting some answers, because You know, we need to prevent this in the future. Thank you.